Alright, here we go. So we've got an explanation of the lab here. So this would be, we go ahead and get started with this. We can take a look at our Fischer representations here of each of the sugars. I'll go ahead and show you the color spectrum here. We can see, of course, here on the, my left, potentially the right on the camera, I'm not sure. We've got that sort of characteristic brown color that's going to indicate that we've got, a pretty high presence of a reducing sugars here. So those are going to be sugars with like aldehydes, like in the free chain form. They would have aldehydes and ketones that would be kind of out there ready to react with that Benedict's reagent. And then of course over here on the right we've got let's see, sucrose. So as expected, sucrose would not be a reducing sugar, so we would see no reaction with the Benedict's agent there. And of course we see it's still blue, still about the same color. I don't have the Benedict's reagent on hand, but of course you can look at your own if you'd like, I suppose. Let's see here. So moving on, we need to draw the Fischer representations of each of the simple carbohydrates for this lab. So we've got lactose right here. We've got fructose right here. Yeah, this one I actually ended up drawing a kind of a strange Fischer projection, just because I didn't really realize that we could just draw a Haworth projection. Yeah, anyways. Moving on to dextrose here, or I guess just D-glucose, right? Well, here, hold on. Lactose would be I've got the IUPAC names here. I don't know. I certainly hope you can read that. I'm not going to read this out right now. That's a lot. So yeah, we've got dextrose here. We've got maltose here, which is in our Haworth projection, of course. Here on dextrose, we've got, of course, the stereocenters here. We have, as dictated in the IUPAC name, we've got 2R, 3S, 4R, 5R, so on and so forth. I mean, they're all written out here. I'm not going to bore you going through all of them. But yes, yeah, so we have maltose here. And then let's see our nice disaccharides there. And then we've got sucrose right here, another Haworth projection, because it is, again, one of those disaccharides. The IUPAC name there. Yeah. And then, yeah, I mean, I guess a quick recap of what it means to be reducing sugar. So yeah, a reducing sugar is just, all that means is that it can act as a reducing agent in a chemical reaction, right? In a chemical reaction with an organic substrate or something like that. Obviously that has, whether a sugar is a reducing sugar or not, obviously has far-reaching implications for, biochemistry and such, and how those sugars are utilized to build, assemble macromolecules and things like that, in addition to be used as chemical messengers even at some points. And then, yeah, just to reiterate, it's really, when we're looking for reducing sugars, we're looking for aldehydes or ketone groups, because obviously those are going to allow those sugars to act as reducing agents. Show your reacted carbohydrates in the color spectrum you achieve, blah, blah, blah. What does that mean? What in your hand-drawn structure identifies each of your positives as reducing and your negatives as not reducing? Sure. So I guess that's a point that I would have missed there, so I'll go ahead and go over that super quickly. You can use sucrose as like kind of our golden example of a non-reducing sugar here. As you can see, I mean, we don't have any aldehydes, any ketones. In fact, it doesn't seem like we have any double bonds at all. Whereas we can go back here and we can look at fructose, and we have a ketone right there staring us in the face. Yeah, so that would make it a reducing sugar, because it would be able to act as a reducing agent in a redox reaction. But yeah, thank you for your time.